For this last video, it's not as much about design as it is about how to work with the data that you get once you've collected the data, okay? Data structures dictate designs. What I mean by that is when you're doing your lab final and I ask you a question, when you find the variables and look at the variables themselves will tell you what data, what statistical analysis to do. Conversely, designs dictate data entry. So if you're doing a between subject design, the data need to go in a certain format. If you're between repeated measures design, the data need to go in a certain format. So I want to talk to you about that in this final video. So the first thing is talk about our different software packages. The first is Excel, the second is SPSS, and Excel doesn't require a certain type of data structure. As long as you know what you're doing with your formulas, you can put your data anywhere you want in Excel. It just doesn't matter. And it doesn't matter how you can put it up and down, sideways, doesn't matter. The user determines the data analysis format. In SPSS, however, SPSS requires a very specific formatting structure for your data, or it won't know how to interact with your data. The software, therefore, determines the data analysis format rather than you. When you ask SPSS to do a t-test, you don't get to tell it also where the data are. You just get to tell it the name of the data that it already has. So my recommendation, because I always start my data in Excel and then bring it to SPSS, is to follow the SPSS data requirements because you're going there anyway. But there are reasons why it's easier to enter data in Excel. If you ever put data in, you'll see that just the ergonomics, the human-computer interface is easier to enter data in Excel. Okay, so here's the big thing, and rewatch the slide. Pause, and when you're done, rewind and go again. Okay, so here you go. Stacking or side by side. Stacking or side by side. Are your samples stacked, meaning sample 1 is on top of sample 2, on top of sample 3, or are they beside each other? Between designs, if you're doing a between subjects design, you must do it side by side. If it's repeated, nope. Between requires stacked data structures. Repeated requires side by side. What do I mean by that? Well, in stacked, you have one column for your dependent variable and one column for your independent variable. And the independent variable tells you what column or what sample the individuals in the between and the dependent column are. So if you think about when we randomly sampled 25 or 50 samples from the EME 500 data set, you made a column that identified what sample they were in. That was your factor. That was, we were creating between subjects designs. That was your dummy column. Side by side, each column is a different sample, either a different trial or a different group. So let's go look at the SPSS data set for EME2 and let me show you these structures like that. So we've got variables that signal between are things like election date or school affiliation, and things that are repeated are when you have different subscales beside each other. So give me a second and let me pull that up and then let's go look at it. Okay, so I want to show you stacked and side-by-side data structures and so that you can think about them in this way. So I mentioned election date as a signal for between subject variance or between subject variable. So for instance, the people that took this before the election date are different people than the ones that took it after. So if I'm doing a between subject design, I'm identifying what group they're in by this here. Another example is affiliation. Do it via variable view. Another factor is affiliation. So different, this says who sampled it, and individuals that were sampled from Georgia are different from individuals that were sampled in New York. Okay? So that is stacked. So let's say you're looking at the degree to which somebody thought MOA importance, right? And so you're looking at differences between the groups on that variable. But if I want to know if MOA independence for importance is different than normative compliance. That's side by side, right? So people gave us MOA responses for both of those. Your lab 9, I asked you to do the idea subscales, right? And so everybody gave me scores for each of those. So now I can compare exploration and negativity, exploration identity, exploration to between. It's side by side. It's within subject, the same person all 4 times. It's between, some of these people were before and some of them are after. And they're all in that same column. Some of these people were before and some of them are after. So stacked, between, side by side, within. It's so important. Okay, those are all the videos for design. Next week we'll start with correlation. I'll see you tomorrow in lab.